Good morning, students. Today we are going to start a new topic in the subject of chemistry, that is the particulate nature of the matter. Here is the statement of the question: which of the following is an example of the diffusion? And here are the options. A part is bubbles rising in a beaker of the boiling water. B part, steam condensing on a cold window. C, water spreading out on a surface of the table. D, hot air rising above a burning candle. And E, the spreading of the smell of the flowers in a garden. So E part is the example of the diffusion. So E part is the answer. So look now, here is the explanation. Choice A, that is bubbles rising in a beaker of the boiling water, shows that air dissolved in water expands on boiling and becomes less soluble in hot water. Choice D, that is hot air rising above a burning candle, is an example of the demonstrating the transfer of the heat by convection currents generated in the air. So the example of the diffusion is the spreading of the smell of the flowers in a garden. Here is another question. The statement of the question is a 50 centimeter cube sample of the alcohol is mixed with 50 centimeter cube of the water. You can see here 50 centimeter cube of the water, and here 50 centimeter cube of the alcohol is being poured into the water. And the statement is the volume of the mixed alcohol and water is found to be 97 centimeter cube. So look now, 50 centimeter cube of the alcohol is being mixed with the 50 centimeter cube of the water. Apparently it should be 100 centimeter cube, but originally it is actually 97 centimeter cube when we measured it from the beaker. Which of the following is the best explanation? And here are the options. A part is some alcohol molecules evaporates. B part, the alcohol molecule fit into the gaps between the water molecule. C part, water and alcohol react to form a gas which escapes. And D part, water and alcohol react to produce a salt which then dissolves. So the answer is B part. The alcohol molecules fit into the gaps between the water molecules. So that's why when 50 centimeter cube of the alcohol is being mixed with 50 centimeter cube of the water, the volume will not be equal to 100 centimeter cube. So it will be equal to 97 centimeter cube of 97 centimeter cube, because some of the volume will be reduced by fitting of the alcohol molecule between the water molecules. So B part is the answer. Explanation is this experiment demonstrates the particulate nature of the matter. Here is another question. The statement is the diagrams shows the spacing of the molecules in a substance at a pressure of 1 atmosphere but at two different temperatures. So this is the temperature having minus 150 degrees C, and this is having at minus 100 degrees C. Which substance could the diagram represents? So here are the options. So substance, option A is minus 183 melting point and boiling point is minus 89. B option is melting point is minus 182 and boiling point is minus 162. C part is melting is minus 169 and boiling is minus 104. And D option is minus 114 is the melting point and boiling point is minus 85. So C option will be the answer, because you can see here is the liquid form. So melting point is minus 169. So this will be the liquid at minus 150. And this is a gaseous form. And the boiling point is minus 104. So this will be in gaseous form at minus 100 degrees C. So C part is the answer, and here is the explanation. From the arrangement of the particles of the substance in the diagram, it can be deduced that the substance exists as a liquid at minus 150 degrees C and a gas at minus 100 degrees C. Thus, it must have a melting point below minus 150 degrees C. and boiling point above minus 150 degrees C but below 100 degrees C. So C part is the answer. Here is another question. The statement of the question is, what can be deduced about two gases which have the same molecular mass? And the options are here. The option is they have equal solubility in water at room temperature. B part is they have the same boiling point. C part, they have the same number of the atoms in one molecule. And D part is they have the same rate of the diffusion at the room temperature and pressure. So the key point for this kind of the question is, if the two substances having the same relative molecular mass, their density will be same and they will have the same rate of the diffusion. So D part will be the answer. So D part is the answer, and here is the explanation. Two gases with the same molecular mass should have the same density and the same rate of the diffusion at a fixed temperature and pressure. Here is another question. The statement of the question is, an inflated balloon will shrink if placed in a refrigerator. This is because the lower temperature causes the gas particles in the balloon to move. A part is faster and become closer together. B is faster and becomes further apart. C is slower and becomes closer together. And D is slower and become further apart. So for the gases, if the temperature is increased, they move further apart and will move further. And when the temperature is decreased, so they become slower and becomes closer together. So the answer must be C part. So here you can see the explanation of the answer. So C part must be the answer. So at a lower temperature, the volume of the gas contracts, resulting in the shrinkage of the balloon. The kinetic energy of the gas molecules is lower, leading to decrease in the frequency of the collision between the gas molecules. So that's why the balloon will shrink. So C part is the answer. Here is another question. The statement of the question is, which diagram shows the arrangement of the atoms inside a balloon containing helium? So C part must be the answer, because helium is a monoatomic gas. That is, actually the molecules are further apart from each other. So here you can see the molecules are closer to each other. In C part, the molecules are further apart from each other. So C part must be the answer, because this is the feature of the helium. So C part must be the answer, and here is the explanation. Helium exists as a monoatomic gas. The atoms are far apart and travel continuously and randomly at high speeds. They collide with each other and the surface of the balloon. So C part must be the answer. So C is the helium gas. Here is another question. The statement of the question is, a beaker of the nitrogen was inverted over a porous pot containing carbon monoxide. So here you can see, here is a pot containing the carbon monoxide, and here is a pot that containing the nitrogen gas. The water level did not change. So here is the water level that did not change. And the statement is, what is the reason for this? And the options are: A, both gases are diatomic; B, nitrogen is an unreactive gas; C, the gas particles are too large to pass through the porous pot; and D, the two gases have the same density. So if the water level does not change, so they will have the same density, and for having the same density, their relative molecular mass should be equal. So nitrogen and carbon monoxide, you will find the relative molecular mass of the nitrogen and carbon monoxide, and you will see that will have the same relative molecular mass. So this is the reason. That's why the water level did not change, because the both gases have the same density. So the answer is D part. So you can see D part is the answer, and here is the explanation. Since N2, relative molecular mass is 28, and CO, relative molecular mass, is 28. So both are having the same relative molecular mass, have the same relative molecular mass. They would have the same density and diffuse at the same rate, at the same temperature and pressure. So this is the reason the water level in the tube did not change. Here is another question. Statement is, which of the following would diffuse most rapidly? A part is Cl2, B CO2, C CH4, and D N2. So the key point for this kind of the question is, first we will find the relative molecular masses of all the options. So the substance which is having the least relative molecular mass will move most rapidly, and the substance which is having the maximum relative molecular mass will move with the least speed. So answer is C part. So explanation is here. Methane, that is Mr is equal to 16, has the lowest relative molecular mass. So that's why it will move rapidly. So this is the answer. Here is another question. The statement of the question is, the cover plates were removed. Here is the cover plate that will be removed from the gas jars shown in the diagram. After several days, the color of the gas was the same in the both jars. The lower jar is containing the bromine gas and the upper jar is containing the oxygen gas, and this cover plate will be removed. So the gases, the molecules of the gases will be free to move towards each other. Which statement explains the change? And here are the options. A part is, oxygen and bromine gases have equal densities. So for equal densities, relative molecular mass should be equal. B part is, oxygen and bromine molecules are in random motion. C part is, oxygen and bromine molecules diffuse at the same rate. And D part is, equal volumes of the oxygen and bromine contain equal number of the molecules. So the answer will be B part, because after removing the plate, the bromine and oxygen molecules are in random motion. So after some time, there will be a uniform color in the full apparatus. And here is the answer B, and explanation is here. The experiment demonstrates the particulate nature of the matter. The reddish brown Br2 molecules diffuse from a region of the higher concentration at the bottom jar to a region of the lower concentration at the top gas jar until they are uniformly distributed throughout the space in the two gas jars. Diffusion of the oxygen from the top gas jar to the bottom gas jar occurs simultaneously. So bromine from the lower to upper and oxygen from upper to lower will move, and diffusion will take place, and after some time the whole apparatus will be of the reddish brown color. So diffusion will be occurred. Here is another question. The statement of the question is, in the Haber process, nitrogen and hydrogen react to form ammonia. Which set of the diagrams represents the molecules of the nitrogen, hydrogen, and ammonia? And here are the options. So nitrogen, hydrogen, and ammonia. And you know, people, that nitrogen and hydrogen exist in diatomic form, and the formula of the ammonia is NH3. So one nitrogen atom is combined with three hydrogen atoms. So ammonia's options will be 1 and 2. And this will not be the option for the nitrogen and hydrogen. So B part is the answer, because nitrogen is found in diatomic form, hydrogen as well, and ammonia is containing 1 nitrogen atom and 3 hydrogen atoms. So B part will be the answer. So B part will be the answer, and here is the explanation. Hydrogen and nitrogen are elemental gases that exist as diatomic molecules. Ammonia is a covalent compound. Each ammonia gas molecule is made up of the nitrogen atom that is covalently bonded to 3 hydrogen atom. Here is another question. This statement is, the apparatus shown is set up using different gases in the beaker. And you can see here is the beaker, here is oxygen gas in this beaker, here is the porous pot, and this is the water level, which is actually X. So X is the water level. Which gas, when present in the beaker, causes the water level at X to rise? So here are the options. A is carbon dioxide, B is chlorine, C is nitrogen dioxide, and D is methane. So for the water to rise from the X level, is the thing necessary is, first we will find the relative molecular masses of all these four options, and definitely the substance which is having the least relative molecular masses, and the thing also important is that relative molecular mass should be lesser than the oxygen. So that will be the answer, because due to which the water level will rise above X. So you can see, after finding the relative molecular masses, D part will be the answer, and here is the explanation. In order for the water level at X to rise, the pressure exerting on the water in the other arm must be higher than the atmospheric pressure exerted on the water at X. Methane gas relative molecular mass is 16, being the lightest gas of the four, because this is having the least relative molecular masses in all the four options, diffuses through the porous pot into the container at a faster rate. Then oxygen gas, that is having the relative molecular masses is 32, diffusing out. This results in more gas molecules in the container and therefore a higher pressure. So water level will rise above the level of X. Here is another question. The statement of the question is, an inflated balloon goes down because gas molecules can diffuse through the rubber. Four balloons are filled with gas, different gases at the same temperature and pressure. Which balloon would go down most quickly? So definitely here are the options, four options. In A part, carbon dioxide gas is given, in B methane, in C nitrogen, and in D oxygen gas is present. So first we will find the relative molecular masses of all these four options, and the substance which is having the least relative molecular mass will go down most fastly. And here you can see the answer is B part, because that will be done after finding the relative molecular masses. And here is the explanation. The balloon goes down the fastest when the gas diffuses out of the balloon rubber faster than air diffusing into the balloon rubber. A gas with the lowest molecular mass diffuses faster than a gas with a higher molecular mass. Since methane having MR is equal to 16 is the least dense of the of all the four options, so balloon B will goes down first. So this was the lecture, students. So read it again, understand it, learn it, and make your notes. Thank you so much.